Even 20 years after Pluto was reclassified as a dwarf planet, there's still a lot of misconceptions about just what this definition means and what separates Pluto from the rest of the planets. Geologically, Pluto is as interesting and dynamic as any of the planets and their moons. It's made of the same materials and is an intriguing geochemical landscape all of its own. It's small, but it's still massive enough to be spherical, and it is larger than many moons of our solar system. But why exactly isn't it a planet? The key part of the IAU's 2006 definition of planet was that a planet has to have cleared the neighborhood of its orbit. This is an important idea to scientists who study how planets and solar systems form, and even before 2006, multiple papers had been written observing the ways that the 8 major bodies of the solar system had cleared their orbits. But what does clearing the orbit mean? In general, we interpret it to mean that an object has either removed or corralled most of the smaller objects in its orbit, leaving it as the dominant body. Sure, there are stray asteroids that cross the Earth's and other planets' orbits, but they are only a small fraction of the planet's mass. Jupiter has vast fields of asteroids that share its orbit, but they're still dominated and controlled by the massive gravity of Jupiter. So what about Pluto? Pluto's orbit crosses the orbit of Neptune. Not only that, but Pluto's orbit is actually affected by Neptune's gravity. I felt like I could really appreciate that with this visual I made for Dr. Renu Malhotra. In this visual, we see a class of objects from the Kuiper Belt, the second asteroid belt of our solar system, out beyond Neptune. We're looking at just one population of Kuiper Belt objects called Plutinos, so named because they have similar orbits to Pluto. All of these objects have orbits in resonance to Neptune. Every 3 times Neptune orbits the Sun, the Plutinos, including Pluto, go around twice. When we watch these objects move together, we can really appreciate this dynamic relationship. These objects move to the furthest parts of their orbit when Neptune is closest to them, and duck back in towards the Sun after Neptune passes by. They're being controlled by Neptune's gravity, which billions of years ago would have cleared out objects that couldn't fall into this resonant pattern. In this way, Pluto and other Plutinos are a window back in time to the processes and conditions that planets form out of, but they haven't completed the final process of dominating their orbits the way the other 8 planets have. Neptune has other evidence of these ancient interactions as well. More than ever, we can appreciate that its largest moon, Triton, is geochemically similar to Pluto, and probably, once upon a time, was the largest member of the Kuiper Belt, but it failed to fall into a resonant orbit that let it avoid Neptune and instead became captured by the planet's gravity to become a moon.